Well, good afternoon. Excuse me. So you guys have to embrace technology, right? And you must have a feeling that Kampala life can also come to Mbara. So I'm sure many of you you are excited. But with time you will get used to. So I am here basically to wind up with my section, a few points, then I'm sure colleague Jude is trying to take you through the revision of the sample of physics, isn't it? Has he taken you through the revision? Yes. So calibration of an ammeter and current measurement as the heading. Where is chalk? Calibration of an ammeter and current measurement. Calibration of an ammeter and current measurement. So we are still continuing with some of the applications or cases where a slide wire potentiometer can be used. Mbarara, we are still very far. But well, God is great. Probably that is why I was deployed in Mbarara, to make sure that I urbanize the village. I urbanize the village. Because literally what is making you actually lose the attention, these are the things you watch on TV. These are gadgets they use on TVs, TikTok accounts and so on. So you want to tell me you don't know this? Get serious, guys. Some of you even have said these things. So let us study. If you have any big deal, you will come and will liaise. Otherwise, you also want to be part of the video. You cannot. And for your information, even when you make any kind of the noise, it cannot capture you. You need this. Honestly. Yeah. The one of sample, Mr. Jude is handling that. Hasn't he come? No, he will. Trust me, he will. So we are seeing how a slide wire potentiometer can be used to measure current, or it can be used to calibrate, my brother. Are you happy? To calibrate an ammeter. Calibrating an instrument is simply giving it a scale, and then it is in position to be used as a measuring instrument. In your heat and thermodynamics, you looked at how to calibrate a thermometer, whereby you look at its glass, place it into an environment that looks like ice. It gives you a reading, you mark the point. Then you get the same bulb. After shaking it vigorously, you put it into steam. Again, the thread rises. You mark the point. Measure the distance, divide it by 100. You will have calibrated the thermometer 2 degrees Celsius. So basically, calibration is an English terminology used to mean giving a scale to something. But as you are giving a scale, in the long run, you are measuring, or you can use that instrument to measure a certain quantity of that, maybe that quantity. For example, if you're calibrating a thermometer, you are intending to be in position to measure temperature. If you're calibrating an ammeter, your intention is to be in position to measure current. If you calibrate, what else can you calibrate? Now what? A voltimeter, the intention is to measure PD. Are we together? Yeah, so now we can as well calibrate an ammeter, and we are in position to measure current. So a lot of components are fixed in this case. We have about 2 variable resistors, the P and Q, which probably in the experiment may actually work as a standard one, because you can fix them at a given value of resistance, then you use that one. We have a resistor, across it is a PDV. We have a source of EMF, E0, which can be used definitely to get a balance length initially before we complete the circuit, to have this part where we have the ammeter, our intention is to calibrate it and be in position to measure a given current. So you can write and say, I am obstructing you. You go and sit behind and be observing from the camera. Okay, connect a standard cell of EMF E0. Connect a standard cell. Most of the work that we are going to do, or that I'm going to read here, is simply about how it works. Then where we need to work, the core objective of why we are applying it is simply a mathematical equation. Connect a standard cell of EMF E0 and a standard low resistance R. Connect a standard cell of EMF E0 and a standard low resistance R, as shown above. Connect a standard cell of EMF E0 and a standard low resistance R, as shown above, full stop. With switches K1 closed, with switches K1 closed and K2 open, with the switches K1 closed and K2 open, with switches K1 closed and K2 open, comma, Doreen, tap the jockey along the you don't want to talk to me now because you don't have a microphone. Along the slide wire, until what happens? Tell them. Let me check if this one works. I give it to you. Battery is over, so we shall share this one that I have here. You have a charger. So tap the jockey with switches K1 closed and K2 open, comma, tap the jockey at different positions along AB until the galvanometer shows no deflection. Another bullet. Measure and record the balance. She has dictated the bullet, Kato. Measure and record the balance length L0. Measure and record the balance length L0 from A to C. Measure and record the balance length L0. All right. Another bullet. P is adjusted so that the ammeter P, a variable resistor P, those who are not seeing it, gift. A variable resistor P is adjusted a little bit such that this ammeter can at least make a small deflection. Then we also close there and go through the other procedure. So P is adjusted so that the ammeter records the smallest current. So that the ammeter records the smallest current. P is adjusted so that the ammeter records the smallest current. So that the ammeter records the smallest current. We can define it as I subscript R, such that the ammeter records the smallest current, I subscript R. Now after that, with switch K1 open, another bullet. With switch K1 open and K2 closed. With switch, I know people want to feel it. Hold the microphone.
You tap the jockey along the wire AB.
Don't say you.
Tap the jockey along the wire AB until the galvanometer gives no deflection. Measure and record the balance length L.
That is another bullet.
Yes.
You tell them another bullet.
Another bullet. Measure and record the balance length L.
Hassan. So she has told us that after adjusting a variable resistor P and then a small current is detected in the ammeter, you maintain switch K1, you open K1 and close K2 such that now you can get the impact of the whole lower circuit apart from the standards, the cell of a standard EMF E0. Tap the jockey alongside the wire AB until when you get a point where the galvanometer shows no deflection. You did that with an intention of recording that length as L. Now, so what? Determine the actual length, the actual current. Determine the actual current, I capital A. Determine the actual current, I capital A, as E naught over L naught times L over R. Determine the actual current IA, which is I subscript A, from the expression the actual current equals E naught over L naught times L over R. Can somebody determine or help us to understand how we come up with this using the previous facts that we studied? Any volunteer can try to show us how we come up with this, or I can leave it as a take home. Yeah? You need some small time? Kato, check. Everybody can try to check and see if you can really come up with that. Or I continue to check during your free time. Irene, check and see how we come up with this. Who dumped Kasashiro close to your docket? That is bullying and teasing. Somebody is bullying you. And this must be Irene. Yeah. In Kampala, there is a game called Anya Karabye. Do you know that betting where people put cards down and then they begin to say Anya Karabye? So who has seen it? You will keep thinking. Then put a comment and say, and end error E, and end error E, and the end error E in the ammeter, and the end error E in the ammeter, and the end error E in the ammeter reading, and the end error E in the ammeter reading equals the actual current minus the other smallest current that we set. Then we completed the circuit for a reading. Full stop. Another bullet. The experiment is repeated for different adjustments of P. The experiment is repeated for different adjustments of P. The experiment is repeated for different adjustments of P. The experiment is repeated for different adjustments of P, and hence for different readings of the smallest and hence for different readings of the smallest current IR. Tabulate the results including values of IR and E. Tabulate the results including the values of IR and E. Is the end error that we are expecting, because for every balance length we obtain it after making sure that there is a small current that flew in the ammeter, or that was detected by the ammeter. Tabulate the results including the values of IR and E. Plot a graph, a calibration graph Plot a calibration graph of E against IR. Plot a calibration graph of E against IR. Plot a calibration graph of E against IR. Full stop. NB. NB, the percentage error in the ammeter reading, the percentage error in the ammeter reading, the percentage error in the ammeter reading equals the end error divided by the actual current times 100%. The end error equals example. So you people always get familiar to generating the theoretical origin of such expressions that we do in experiments. Because if you know it in your procedure as you are trying to display the steps that you undergo or you go through to determine what the experiment is asking for, at least you know where you are heading. You simply have to know the theoretical origin of such expressions. I'm sure if you take your time, you will come across it. But it is generated from the balance length. E naught equals K what? L naught, where K is PD per centimeter, and of course the first place you had that, the second place you will have V equals what? KL, right? When you divide the two, you will have something like, if I can call it V over E naught will be L over L what? Naught, isn't it? So because you are looking for I, the intention is to calibrate an ammeter or to measure current. You substitute for V with or by Ohm's law, which is IR equals E naught over L naught, right? If I take this times L. So if I divide by R, I think I will come to the other expression. Where is it? That one there. So get familiar to generating those expressions from the theory that you know. An example. In the circuit diagram below, in the circuit diagram below, in the circuit diagram below, S is a standard cell of EMF 1.2 volts. S is a standard cell of EMF 1.2 volts. In the circuit diagram below, S is a standard cell of EMF 1.2 volts, a full stop. When switch K1 is closed and K2 is open, when switch K1 is closed and K2 is open, when switch K1 is closed and K2 is open, a balance length SC equals 30.2. a balance length AC equals 30.2 centimeters is obtained. Full stop. When K1 is opened and K2 is closed, when K1 is opened and K2 is closed, when K1 is open and K2 is closed, comma, the balance length is 26.8 centimeters. The balance length is 26.8 centimeters. And the ammeter A reads 0.4 amperes. And the ammeter A reads 0.4 amperes. Calculate the percentage error. Calculate the percentage error in the ammeter reading. Calculate the percentage error in the ammeter reading. Calculate the percentage error in the ammeter reading. Do I have a volunteer who wishes to directly carry out substitutions? Gift, are you willing? My brother, Clever, can't you chop this? Come and be helped by the class. Those days you used to be very good at presentations. I don't know who demoralized you. So you come and pick up the morale. Come and we help one another. I even give you my microphone. No, I need to capture the audio in my video as well, such that I tell my people that that one is called Clever. Let me fix it here.
Okay. Good afternoon, class. Provided the question, and we are saying that calculate the percentage error in the diameter reading. And we all know that the percentage error is equaling to times 100 what? Percent. And to have this, do we have this? According to the question, do we have it? What about this? Yeah. So now we are going to find E first. IA, which is okay. Finding IA, and it is equaling to E naught over L naught times L over, what is our E naught? 1.2 volts. Then our L naught is 30.2. L 26.8. Then our R, it is 2. Okay. Using your calculators, you just calculate this and tell me the answer here. 0.532 5. Do you have the units? Amperes. Okay. So now, since you have got this one, we can now find E. Then finding E is IA, IR. Our IA is 0.5325 minus 0. Only? Okay. Then our E will be equaling 0. I think the amperes. Now, finding the percentage error we are going to have, our E, which is 0.1325 out of 0.5325 times 100%. Using the calculator, Travis, tell us. 24.9 only? Okay. So therefore, we are saying that the calculate the percentage error in the diameter reading. So the percentage error in our diameter reading is 24.9%. Okay, this is the ammeter.
Thank you. Let's appreciate the Well, I don't see any logic there. I'm not seeing any logic there. It's direct substitution. Hmm? Calibration of voltimeter. You know, one thing that most of the times makes it a little, complicated, most of the times are the many components that are put in the circuit. And you end up actually not talking about them. For example, the previous circuit, we had a variable resistor, Q. And even here we have it that we end up not talking about. But in the calculations, that's when you see its meaning, whereby you're supposed to maybe find that constant current that flows through the slide wire that will help you get the PD per centimeter. So most of the times, of course, as you're redrawing the circuit, you need to master those components that are a must be part of the circuit diagram. Because once you miss out the point, you might have a circuit diagram where you talked about a variable resistor in your explanation, but in the circuit diagram, that variable resistor does not exist. It will be an implication that you are copying somebody. So as you are writing all the literature about your circuit diagram, make sure that whatever you're talking about in the diagram, in your literature, exists in the diagram. Another thing I told you, that when you're drawing the diagrams here, make sure that these lines are connected where they're supposed to be connected. If you leave out anything like me, I'm drawing, because of course at the end of the day, I'm going to rub it off and nobody is going to give me marks. Even whatever I'm recording, I want simply to put it on YouTube. Number one, for record purposes, that I was a teacher some years ago. Pardon? My real name are the one, my real names are the ones I use. So please make sure that the circuits or the wires, the connecting wires in the circuit diagram are connected. If a wire is coming from, let's say, a resistor, and then it must be connected, don't do this. Because once you do that, these people who are marking, they have the time. They will circle that. I will not give you a mark. A standard cell of EMF E naught, well, we are talking about the circuit diagram. A standard cell of EMF E naught, a standard cell of EMF E naught, and a rheostat P, and a rheostat P. Rheostat is RH EOSTAT. A standard cell of EMF E naught and a rheostat P are connected as shown above. Are connected as shown above. Was it above or below? Above. Switch K1 is closed while K2 is left open. Switch K1 is closed while K2 is left open. Switch K1 is closed while K2 is left open. Doreen. Avoid the word we or you. That's where you can stop. I'm sure you are bulleting them, right? Hey, you're not writing a biblical verse. That's how far you can go. the PD percent meter K after you have noted all what she has told you to note. From the other point of closing the switch, tap the jockey along the slide wire AB until when a balance point or a point where the galvanometer shows no deflection is obtained. Measure and record that balance length as L0. The PD percent meter K is, of the slide wire is calculated from the PD percent meter of the slide wire is calculated from now people are waiting for me to tell them how it's calculated. They're waiting for me to tell you how the PD percent meter is calculated, right? Okay, it's calculated from V equals IR. Are you sure it's calculated from V equals to IR? You write the formula for determining the PD percent meter K. Having closed the switch K1, then you tap the jockey along the slide wire. How do you get the PD percent meter of that slide wire? Yeah. You man, tell him how to get the PD percent meter. How do you get it? Let me see. Open. Are you writing?
Yes.
Open where you're writing. How do you get the PD percent? Open the book. If I'm going to slap you, I will slap your ears properly. This is peace. Open, we see how you get the PD percent meter. How do you get the PD percent meter? But when you were not there, again, you did not ask your friends. How do you get the PD percent meter, you man? Wapi? Rubbish. When we close switch K1, it means that the lower part of the circuit is not part. It's not contributing. So you only have the EMF E0 and then the balance length L0. You can't use those two to get the PD percent meter. That one I will not open up your eyes. So you write the expression for finding the PD percent meter, then you label it as equation 1. Another bullet, P is adjusted so that the voltimeter records the smallest PD. P is adjusted so that the voltimeter records the smallest PD. To record the smallest PD. VR. The smallest PD, V subscript R. K1 is then K1 is now opened, and then K2 is closed. Yes, Doreen. Make them bullets, because when you're revising, that's when it will be easy for you to remember. After you have opened the switches, you tap the jockey along the slide wire until when a balance point is achieved, when the galvanometer shows no deflection. Then read and record, or measure and record the balance length as L. where after measuring and recording the balance length as merely L, the remaining work is algebraic gymnastics. The actual PDVA is going to be from K, L, right? You label this as 2, right? Then substitute for what? For K, which is from 1. What do you get? Good. So NB, there can't be an N. Yes, sir. This is senior 6 physicists. Chongozi yenyu yuko wapi? Pardon?
Afanye physics? No.
I don't. He's a biologist. I think this one is a representative for the physics class.
I made it suggested for last disciplinary policy, but there are some people who are not serious. Then there's a company about this class that we're using to store. So we need to from today. Don't use the dog. We run there, then you do for a big okay. Now we are going to do that. Make it better. Close two blocks. Next to cancel the next to the by today. Shift them.
So there is also an end error in the voltimeter, because remember that before you close the switch and tap the jockey, you adjust a variable resistor for the voltimeter to give a smallest reading. So that error is going to be VA minus V what? Yeah. Minus VR. And also the percentage error equals the error over the actual PD times 100%. You see, you witness the fact that at least you people have matured. I'm sorry to mention this young girl, she's a friend of mine. When she came here, this girl here, when you could offend her, you remember in S5, she could cry. Yeah, don't you remember? But now, even if you make her a topic of the subject, she cannot. She has matured. But those days, whenever you could be like, we're having a class at night, she could cry. You see, teacher, you see, I'm like, but then me, I have nothing to do. I am following what? Orders. But now she's very comfortable. She can even dodge a class and she's comfortable with it. So at least you realize that you keep on maturing. You keep on maturing. And that is what life is all about. Yeah, that's what life is all about. Today, we are in this room. I always tell the audience that today, I'm in this room as a teacher. Tomorrow, I am going to be in a certain room when you are the instructor. Maybe you are the teacher. Or maybe you are the boss. I can, at one time, bring my application in your office asking for a job. So that's what life is. You realize that you mature. There is a teacher here who is teaching biology. It's called Mogera. He was trying to tell me that he taught a certain boy, as we talk today, is one of the senior bus drivers of Taus Bus Company. He taught him biology and chemistry. So now, why are you laughing? You are laughing at where the comparison of biology and Taus are coming in. No, but now the teacher is enjoying the benefits of teaching the boy. Every time he's going to Kampala, he gives him a call. Are you leaving? Yes, sir, I am leaving. You find me at this. Then is called what? Chero. Or this one here, first Meru A. So as we talk now, those days the teacher was the driver and the student was the passenger. As we talk now, the teacher is the passenger and the student is the driver. Comparison of two resistors, a subheading. Comparison of two resistors. A minute. Gloria, I'm in a brief meeting. I'm calling you back in a short while. Yeah. Wanji? Okay, I'm going to call you back. Let me first finish the meeting. So now you people, as I declared some time back, it's high time you started carrying out experiments, practical experiments that involve using a slide wire potentiometer or a meter bridge. I've so far received one candidate. So the rest, you should also wake up and follow the same footsteps. Time is against me. What is it, Doreen? You are disturbing the gentleman. No. It's not disturbing His Excellency. Well, connect the two resistors R1 and R2 in series. Connect the two resistors R1 and R2 in series. Connect the two resistors R1 and R2 in series with an ammeter A. With an ammeter A. With an ammeter A and the rheostat P as shown above. With an ammeter A and the rheostat P as shown above. Bullet 2. Close switch K. Close switch K. Close switch K. Bullet 3. With the galvanometer at point A and B. With the galvanometer at point A and B. Meaning that you connect the galvanometer at a point B such that the circuit runs like this. It runs like this. Like this. It only entails resistor R1. So the galvanometer is at a point where only R1 is considered in the circuit. R2 is ignored or neglected. So with the galvanometer at points A and B, Doreen. You are tapping what? The jockey along line what? So in your labeling, you realize that when the galvanometer is at point B, the jockey is at a position J1, right? Then when we shift it to a position C, it goes to J2. So in your circuit, it must also be shown. Continue. You're done? Well, so that one, when the joke is at a point B, what does that mean, therefore? It means that V1 equals what? Equals K L1, right? But V1 is I R1, which is K L1. Call that equation 1. Another bullet. Connections A and B are removed. Connections A and B are removed and replaced by connections A and B are removed. In other words, we remove now the galvanometer from here, put it here, then we also disconnect this and make it just like we have shown it with the dotted lines. So we bring this point A here, capital, then we bring the galvanometer from there to there, such that now we are having a resistor R2 whose PD across its ends is V2. So connections at A and B are removed and replaced by those at B and C as shown by the dotted lines. And replaced by those at B and C as shown by the dotted lines. The balance length is measured. Of course, I have not called Doreen because we assume that you know what next. Tap the jockey along the slide wire AB and then look for the balance length L what? L2. Are we together? All right, so the balance length L2 is measured and recorded. Hence, the balance length L2 is measured and recorded. Hence, I2R2 equals KL2. So that one is equation 2. So if you divide 1 by 2, divide 1 and 2, convince yourselves that you will get R1 over R2 equals L1 over L2. Example. Now, in the experiment, the factual experiment, we are shifting the connections from a point, capital A, small a, to capital A, small b. But some of the calculations, you will actually be shifting the galvanometer from here to there. Are you observing that? When you shift the galvanometer from here to here and you didn't shift this wire from here to there, then it means the two resistors will be of influence. So the other current I2 equal, IR2, for the case where the galvanometer only was shifted to here, it will be the effective resistance of the two. Are we together? If you only tamper with the galvanometer from here to here. Are you getting the point? If you only shift the galvanometer from here to here and you leave this dotted line as it was initially, it will mean that even R1 is influencing the balance length L2. So when you are taking V2, it will be running from here to here, of which the resistance is going to be effective and the two resistors are in series. So your IR2 in this case, it will be I into R1 plus R2. Are we together? As we are seeing in this example. The circuit below is used to compare. The circuit below is used to compare. The circuit below is used to compare the circuit below is used to compare the resistance R of an unknown resistor. The circuit below is used to compare the resistance R of an unknown resistor with a standard 100 ohms. The circuit below is used to compare the resistance of R, the resistance R more chalk or more pieces of chalk. The distance is L. The distance is L from one end of the slide wire. The distance is L from one end of the slide wire. The distance is L from one end of the slide wire of the potentiometer to the balance point are 40.0 centimeters and 58.8 centimeters. 40.0 centimeters and 58.8 centimeters respectively. When G is connected to B, when G is connected to B and then to C respectively, and then to C respectively. Full stop. If the slide wire is 1.00 meter long, if the slide wire is 1.00 meter long, ladies and gentlemen, find the value of R. Find the value of R. When Gift went to bring chalk, she brought these two pieces. You see? An implication that there is no more chalk. And I cannot go beyond that. So I can leave that for you people to try. But put everything in consideration. I beg to stop there.